Hey guys, here's a quick little video doing one of the examples from the homework just to help you out in case you need a little more guidance. You do have that one other example we had from class, but here's a different one just so you can look at it if you need it. So I plotted the points already, and of course we're trying to figure out what type of triangle this actually is. The first thing we're going to do is check out the side length so we can determine how to classify it by the actual sides. So we can go ahead and use our distance formula, so I'll start out with AB. So AB is going to be, let's see, we have 8 minus 3 for the first part, and we have 2 minus negative 3 for the second part. And that takes care of AB. And it's always good to label which one you're doing so you don't lose track. And if we simplify that properly, we get 5 squared here, plus, this is going to be 2 minus negative 3, so that's another 5 squared. And of course, that's 25 plus 25, so that's the square root of 50. So there's your AB. Let's do BC. BC is going to be, let's see, 3 minus 8 for one part, and 7 minus 2 for the other part. And simplify that. That's going to be negative 5, but be careful, that negative 5 is squared in its entirety. It's not just the 5 part. So it's negative 5 squared. A lot of you guys in class the other day were putting something like this. I'll just write it here on the side like this. You would write that on your paper, and so then you'd think that that was negative 25. But while that's actually true, the negative 5 is supposed to be in parentheses, which would actually make it positive 25. Because negative 5 times negative 5 is positive 25. So that'll take care of that. And then this actually is just, oops, plus 5 squared there. And we do end up getting the same thing. 25 plus 25 is square root of 50. So right off the bat, I know that AB and BC are the exact same thing. The only thing I have to check now is to see if AC is the same thing. If AC is the same thing, then all three sides are the same, and I've got myself an equilateral triangle. But as it turns out, from A to C, especially, actually, it's just a horizontal segment. I could just count the boxes if we want. But I know some of you like to use the distance formula no matter what because you're not 100% sure. But to save time, you could just count. From A to C, it looks like we're going from negative 3 to positive 7, which is 10 units long. You could literally just stop there and say AC is 10. But again, just for the sake of showing all the steps, for those of you that want to see that, I'll use the distance formula one more time. So I have 3 minus 3 squared, plus 7 minus negative 3 squared. And that's going to be 0 squared, of course, plus 7 minus negative 3 is 10. So 10 squared is the square root of 100. The square root of 100 is 10. And even if you didn't end up getting 10, you can see clearly that it's not the same as the square root of 50. Now, I'd like you to see that it's 10, but worst case scenario, at least realize that we have two sides here congruent. So right off the bat, we can figure out this is an isosceles triangle. Okay, we have at least two sides congruent, but not the third side. All right, so we're halfway home. Actually, we're really more than halfway home. We did a lot of work there. The other thing we have to do is determine if this triangle is actually a right triangle. Okay? In order to do that, if you look at the notes from Friday, you saw that we had to check out slope. Now, the only possible place that we could have a right angle in this type of triangle would be here. That's the only potential. Because if we're going to have it here, since this is an isosceles triangle, it would really have to be here also. You can't have more than one right angle in a triangle, so the only logical place would be here. What we said in class was to look for the two shortest sides, and then the angle that potentially could be the right angle would be in between those two sides. So in this case, square root of 50, of course, is smaller than square root of 100, which was the 10 that we got before. So the only, again, possible location is here. So we need to use slope. So find the slope of AB, find the slope of BC, and let's see what we get. So I'll do that. Let's see, I'll do that over here on the side. So the slope for AB is going to be, let's see, AB. So that's going to be 8 minus 3 over 2 minus negative 3, which is 5 over 5, which is 1. So the slope of AB is 1. Now, again, the formulas you should have on your notes page. I'm just using the slope formula, of course. And now I just need the slope of BC. Slope of BC. BC, let's see, that's going to be 3 minus 8 over 7 minus 2. 3 minus 8 is negative 5. 7 minus 2 is positive 5. This becomes negative 1. So I have a slope of positive 1, a slope of negative 1. You could look at it two ways. The product is negative 1. You could look at it as the opposite reciprocal. The reciprocal of 1, of course, is still 1. This is positive, this is negative. We do have perpendicular lines. So we do, in fact, have a right angle here. So this is a right isosceles triangle. Okay? So find your distances. See what type of triangle it is by its lengths. Find slope. See if there's a right angle hiding in there. Oops, sorry. If there's a right angle hiding in there, that'll tell you if you have a right triangle. And the rest should be just a matter of doing the calculations properly. Okay, hopefully that helps. If you have any questions, of course, post them, and I will talk to you guys later.